Hello, NASA staff and NASA interns. My name is Jaden,
I'm Ethan.
and our theme is analyzing the solar eclipse effect on energy generation. Our research topic is what effect, if any, does the solar eclipse have on solar power generation, and to what extent does it affect the solar power generation in the state of Texas? Our exigence was the increased interest in solar energy as well as the need for effectively preaching the importance of solar energy.
Our research area is the state of Texas due to its extensive data and being covered fully by the solar eclipse. As you can see here in the data, the total solar eclipse and the 90% totality perfectly covers majority of where our data set is providing the data for. The data source we used is the Electric Reliability Council of Texas.
So for our analysis process, we were conducting three t-tests for a difference of means. The first t-test was conducted using solar power from the 30-minute interval in which the April 8th solar eclipse was occurring, and it compared that to values for 30-minute solar power generation throughout the month of April. The next t-test was conducted using the total solar energy generated from that day and comparing it against standard daily values for solar power generation. And the final t-test was conducted to compare the daily energy generation in all forms, such as gas or biomass, during the solar eclipse with the daily energy generation on normal days to see if any energy lost during the solar eclipse was compensated for. The results were evaluated on a basis of their p-values and standard deviation. So tests 1 and 2. Test 1 was testing for the difference in solar power generation for a 30-minute interval. The null hypothesis was the solar generation within the 30-minute eclipse interval would be the same as the solar generation within 30-minute normal intervals. The alternative hypothesis, however, was that the solar generation during the eclipse interval would be lower. The conditions were all met except for the large sample size, which was n equals 29. N equals 30 is usually considered a large sample size, but for our case of studying, and since there were no significant outliers, n equals 29 is sufficient. So for some results, we conducted the t-test and it was deemed statistically significant with a p-value of 9.99 e to the negative 16 and a standard deviation of 1.7 thousand megawatt hours. Now, as you can see here, this is a very significant p-value, so it would have been impossible for this to occur under normal influence. Test number 2 was testing for the difference in daily solar power generation. The null hypothesis being the daily solar power generation is the same, and the alternative hypothesis being that the solar power generation during the eclipse was lower. Now, the conditions were all the same except for the large sample size. This time, there were a few outliers, likely on either cloudy or rainy days. The results were still statistically significant. However, it was with a much higher p-value. This standard deviation was a lot greater, but this is total for the day, so it makes sense. And since the p-value was a lot greater, and as we can see on the graph, it was a lot closer to the middle, so it would be a lot more likely to happen under standard conditions. However, this is still a statistically significant result. In conclusion, for both tests, we are able to reject the null hypothesis and state that our data favors the alternative hypothesis, suggesting that the solar eclipse has a negative effect on solar power generation on both a 30-minute interval and daily level.
Now, as for total energy variations, our null hypothesis for total energy variation was that the daily energy generation is the same as the daily energy generation during a solar eclipse. And our alternative hypothesis was if the daily generation during the solar eclipse was lower, with our conditions mostly met with it being a random sample and one off from large sample, but that's close enough because of how extreme our result was, and it being an independent sample.
We could use t-test.
We got the result of p-value being 1.179 to the 10 to the negative 7th power, and our standard deviation being 77,187, meaning it's statistically significant. As a conclusion, we reject the null hypothesis. This data suggests that the total energy generated during the day of the solar eclipse is less than the energy generated on other days. This may mean that despite the lack of solar energy on April 8th, the state of Texas did not compensate for the energy lost.
So on to our final statement. So for our research conclusion, from this research, we learned that the solar eclipse of 2024, that there was a significant decrease in energy generation throughout the state of Texas. Solar energy generation was first notably lower, and this may have also led to decreased overall energy generation. We also noticed that this energy lost in the solar form was not particularly recuperated by increased energy generation in other forms, such as gas or biomass.
These were the ups and downs for us in this program.
Now onto our personal reflections. I'll start. NASA Seas has made a big impact on me so far. I mean, throughout NASA Seas, I've learned how big of a difference NASA makes and how many fields NASA studies just besides space. I've also learned about the history, its missions, and it has changed my perspective of the world entirely. As for how it might impact my future, well, throughout this research, I've learned a lot about data analytics, managing data, communication professionally, and all of these skills that I've learned from this project will definitely help me, especially since I'm planning to study environmental sciences in the future.
And as for me, as an aspiring engineer and a science enthusiast, this NASA internship reinforced my passion for science as well as giving me new perspectives on the climate and the environment. This program grew my interest in environmental science and aerospace, and I hope to use this experience in my future engineering journeys. And with our final statements, we would like to thank our mentors, Mr. Femi, Mr. C, Mr. Grant, as well as Globe Mission Earth for their great leadership and guidance. We would also like to thank our supportive teammates for their constructive feedbacks and engaging discussions. Thank you.